Hello, welcome to another study section. Today we'll be handling another CyberDefenders lab, and today's lab is PacketDetective lab. I've opened a lab here, so let's read what this lab is about. Welcome, and let's do this lab together. So the instruction is: analyze network traffic in pickup files using Wireshark to extract IOCs and reconstruct attacker tactics like authentication and remote execution. So we're going to use Wireshark as our tool. This is web-based lab. We don't have to download the artifact into our system. So let's go straight. What's the scenario? In September 2020, your SOC detected suspicious activity from a user device flagged by unusual SMB protocol usage. Initial analysis indicates a possible compromise of a privileged account and remote access to usage by an attacker. Your task is to examine network traffic in the provided pickup files to identify key indicators of compromise and gain insight into the attacker's methods, persistent tactics, and goals. Construct a timeline to better understand the progression of the attack by addressing the following questions. So I think we have 3 different pickup files. Yeah, so let's open our first one before going to answer the question. Prefer to make it full. So our first question is: the attacker's activity showed extensive SMA protocol usage, indicating a potential pattern of significant data transfer or file access. What is the total number of bytes of the SMB protocol? So this is quite straightforward. We can get this. So I think we are dealing with SMB protocol testing. Yeah, okay, just about 32 packets. So to get the number of bytes, we go to statistics, protocol hierarchy, and we'll look for SMB. So this is SMB. So let's trace how many number of bytes. Yeah, this is it. This is. I'm sure we are on the right track. SMB. Let's highlight it so that 4406. So I think that should be our answer. This is quite easy to get. Yeah, 4406. Okay, that was good. Then our next question is: authentication through SMB was a critical step in gaining access to the targeted system. Identifying the username used for this authentication will help determine if a privileged account was compromised. Which username was utilized for authentication via SMB? One of the easiest ways to get username is through the slash, like the username comes after this. Okay, I'll show you what I mean. So let's search for SMB. Almost all the packets are for XML. So let's look for, what's the question again? Authentication through, okay, identify authentication. Yes, we are just looking for one username used for authentication. I didn't intentionally put my mouse here, but yeah, so session sector and X request. So easy way is to just get it through like the slash. So the username, see the user comes after like the slash, and this is our username that we are looking for. But I think there are other ways we can also get this. You can come here. Let's see if we are on the right. Wait, what? Why is this by this side? I need it. I don't need. I want this thing changed. It's going to. Where was I? Please. I've always used okay, section stuff and it's here my so this is it. This is our username, administrator. So this is another way of getting the username. And I think you will follow the TCP stream. You can also get the username around here. Okay, am I not searching the right group? Okay, yeah, this is it. So this process is a bit technical to me, so that is it. Let's go. Okay, that's correct. During the attack, the adversary accessed certain files. Identifying which files we accessed can reveal the attacker's intent. What is the name of the file that was opened by the attacker? Let's come back here. Let's go through because you'll definitely see. I'm trying to create a lot of space. I don't know. Okay, this looks better. Yeah, where was I? Okay. And somehow we just get to the file itself. So now, like I always said, I like to look at when I see a tree, when I'm looking at a packet, I look at the name, the name of number that occurs after the slash. So this should be what's the word? The file that was accessed by the, if you follow the path that was accessed by the attacker. So, and it's just here to file name / event log. So this is our answer. It always doesn't happen like this frequently. Sometimes you have to like dig deeper to get your answer. So let's see something. This is easy. So this is an easy level lab. Am I talking too much? Clearing event log is a common tactic to hide malicious action and evade detection. Pinpointing the timestamp of this action is essential for building a timeline of the attacker's behavior. What is the timestamp of the attempt to clear the event log? Usually, okay, you might be wondering why virus total is here. I try to access the file. Okay, it's just always on because you cannot be so sure, right? So I even forgot it. Timestamp of the attack of the attempts to clear the event log. So this is when it happened. Let's go down to see if we can see a packet that tells us directly what. Now this is the clear event log. You can just look at the timestamp instead of having to go through everywhere. Let me see something. Yeah. Okay, let's just check from here and change the timestamp so that you'll be able to see time here. So what is the time? Year, month, day, year, month, day, minute here. So the year 2020 0923, 2020 0923, 1650. 16. So we are done with the first pickup file. So we are going to the second one. Okay. The attacker used named pipes for communication, suggesting they may have utilized remote procedure calls for lateral movement across the network. ROPC allows one program to request services for another remotely, which will grant the attacker unauthorized access or control. What is the name of the service that communicated using the named pipe? I've had to research this, but let's see what we can get about this. A remote procedure call is an inter-process communication protocol that allows the program to execute a function or subroutine on a different system or server across a network. It abstracts away the complexities of network communication, letting developers. Okay. So in your private time, you can to read more about remote procedural files. But for now, what's this? Okay. So what I'm going to do is, what is the name of that is using that communicator using the named pipe? So I'm just going to search for the pipe this thing. Let's see if this is going to work. Where am I here? Okay. Okay. Okay, so Okay. Okay, so since we're going to do filter first of all. The remote procedure calls, we're going to filter the remote procedure calls. Where were we before? Yes. So we're looking at this before. So let's follow the TCP stream. So we're going to look for pipe. When it gets here, it's kind of difficult for me because it's not like together. So you will have to follow it line by line to get what you want. So line by line. If you see it before me, you point it out. So pipe. You're going to look at the pipe figure. Okay, yeah, I'll send the pipe. Okay, so you said, and I think there's a ATSVC. Let's try ATSVC. Oh, that was okay, whatever the case. So that was a bit challenging for me. Was it challenging? I just asked for the specific stream. Measuring the duration of suspicious communication can reveal how long the attacker maintained unauthorized access, providing insight into the scope and persistence of the attack. What was the duration of communication between the identified addresses? One. Okay, we'll come back to check. Let's check for the communication. So this is quite. You're coming here. Conversation because it's between two IP addresses. Just IP addresses. So we'll come to IPv4. The IPv4 addresses 172.16.661 and 36.10.36. So it's this. The duration. What was the duration of communication? Okay. 11.7247, 7247, 7247, 7247, 7247. Okay. We are done with the second PCAP file, so we're going to the third. The attacker used a non-standard username to set up requests, indicating an attempt to maintain covert access. Identifying this username is essential for understanding how persistence was established. Which username was used to set up this potentially suspicious request? You know my hack for username. So, okay. I think we've gotten our username. Session setup request. Yeah. To set up request. So username to session setup. And our username is /backdoor. Even if this is username, remember it comes after the slash. Is it forward? This is backward slash, right? Forward slash, forward, backward slash, backdoor. So the attacker leveraged a specific executable file to execute processes remotely on the compromised system. Recognizing this file can assist in pinpointing the tools used in the attack. What is the name of the executable file utilized to execute process remotely? So we just search for executable file. So I would have, okay, let's just filter first in this one. Since there are other protocols so that we'll know what we are working with. We are looking for a create request. Okay, so this is our answer. So our answer is P. I don't want to have to. Yes. EXE. .d. Right? I don't have to do it. So, ladies and gentlemen, we are done with this lab. So, thank you for coming, for studying with me and doing the labs together. I will see you in another lab.